Welcome everyone to lesson 6, the final lesson from this section. So we're going to be looking at applying operations to unlike algebraic fractions, and there's going to be different denominators. So this is as complex as it can get for you guys right now. So first of all, pause the video and spend 6 minutes working through the retrieval task. Okay, and here we go. Here are your answers. So again, the practice, seeing these kind of things now, you should be starting to notice that 196 is 14 squared. So the square root of 196 is 14. We know that this little squared term, or 8 to the power of 2, or 8 squared, whatever you prefer to call it, it means 8 times 8, so we get 64. 1 squared, or 1 to the power of 2, is going to be 1 times 1, which gives us 1. So when we find the difference of these two, we know it's 63. Again, the area of a triangle, we know it's half the base times by the height. So the base is 10. The height is 4.8. So when we times them together, we get 48. If we divide that by 2, we get 24 centimeters squared. And again, so this sort of thing here with our fraction on C, we know that 1 whole 1, if we've got two denominators here that are 41, we want our 1 whole 1 really to be represented as a fraction over 41 as well. So that'd be 41 lots over 41. Then we've got all our denominators the same. So all we have to do is do 41, take away the 3, which gives us 38. 38, take away the 7, gives us 31. So we get 31 over 41. Give yourselves a mark out of 6, and then we're going to move on. So here we have two examples of algebraic fractions. Now these are called algebraic fractions as they have an algebraic term, so a variable or an unknown, on the top and on the bottom. So as you can see in our numerator here we have an x, and in our denominator here we have x squared. In this one here we have an a term in the numerator with our 2a, and then we have an a term in our denominator in the 3a part of 3a plus 2. So the rules that apply to numerical fractions, so just fractions with standard numbers, also apply to algebraic fractions. So for example, if we divide or multiply the numerator and the denominator of the fraction by the same number or terms, we produce an equivalent fraction. So just like we've done in the last few problems, or just when you're looking to simplify a fraction, when your question asks you to fully simplify, if you divide the top and the bottom by the same term, then you still get an equivalent fraction. If you multiply the top and the bottom by a certain term, you still get an equivalent fraction. As long as you're consistent on the top and the bottom, you will still have an equivalent fraction. So let's have a look at an example, eh? So we've got 3x over x squared. So what we've done here is they've taken out, so if you think we've just divided through top and bottom by x, which means this x cancels, and then we've divided through by x on the bottom, which means that this x, it would be x times x, so we'll get rid of that. So we don't know what the x is, but it's almost as if we were taking out a factor of 2. It's the same theory, it's the same in essence, except we don't know what the x is. But we've divided the top and the bottom by the same. So now look, what have we done now? So now we've times top and bottom by 2. So we can see that 3 times by 2 gives us 6, 4 lots of x, times by 2 gives us 8 lots of x. All still equivalent. Next, what have we times by? Okay, so next we've times by a half y. Now this pattern spotting, you will get better at once we get a chance to go through it. But if we have a look, 6 times by a half gives us 3, and we're also timesing by y, so that works. 8 lots of x, so we're timesing the 8 by a half gives us 4. We've still got the x, and we're timesing by y, so that works as well. And as you can see, so if we look back to, it's not as muddled. So if we look back to this fraction here, this is equivalent. What we've done is we've times this top and bottom by a plus 2. So this is what it means when we say that if we're multiplying by the same number or the same term, so it's just a more complicated version. So we've times through by a plus 2. So the top's been times by a plus 2, whatever that is, and the bottom has been times by a plus 2. So that's still an equivalent fraction. So let's have a look at some examples. So first of all, I'd like you to put, so yes, just like I did on the last one, very low stakes. You can do this on a scrap piece of paper if you'd like, or in your notes. Can you try and deduce, can you try and figure out what the multiple or the division is that's taking us between these equivalent fractions? Pause the video and give yourselves 30 seconds trying to figure out. No, a minute. Give yourselves a minute. Okay, so here we go. So on the top, I can look and see that we've gone from t squared to 8t squared. So the t squared stayed the same, so we times top and bottom by 8. So that on the bottom will give us 5 times 8 gives us 40. And then we've still got the t. We're still multiplying by 2. So then here, what have we times by? So what I can say is that it looks like we've dropped to t. So I'm going to say that we're dividing by t, because t squared divided by t would leave me with just one multiple of t. And then we've also lost our 8, so our coefficient has become 1. So we've divided through by 8 lots of t. So we're going to have to do the same on the bottom. Divide through by 8 lots of t. So the t divided by the t, we're going to end up with no t. And 40 divided by 8 is going to give us 5. So next of all, what we're going to do is we need to go from 1t to 6t. So I think we've times through there by 6. So on the bottom, we're going to also have to times through by 6. So that's going to give us 30. Give yourselves a mark if you got all that right. Again, it was low stakes just to see how you took to it early on in the lesson. If you struggled with it, that's no problem at all. We're going to go further and deeper into this with a lot more examples. So, a fraction can be written in the form a plus b all over c. So that can be written as, so I'd like you to make a note of this please guys. So that is allowed. We can break up our a and b and do them as 2 separate fractions. However, if a fraction looks like this, that we have here, c over a plus b, that cannot be written as c over a plus c over b. So you can break up the numerator into separate fractions, but you can't break up the denominator. And I know that that can look confusing to start with, but this slide gives you a really good example of how you can figure this out. So what we're going to do is we're going to use an example. So we know that on the top here, 1 plus 2 gives us 3. Our denominator is 3. So that answer is just 1. So if we have a look at splitting them, like we've done here, so we end up with 1 over 3 and plus 2 over 3. So 1/3 add 2/3, that does give us the 1. So that works. And all we've done is we've said, okay, from our top example here, which we said we can do, our a is equal to 1. our b here is equal to 2, and our c is equal to 3. But, and now this is a but what looks at the thing that we can't do. So I'm just trying to that's odd. Struggling to get a rubber. So, but 3 over 1 plus 2, that does not equal 3 over 1 plus 3 over 2. So what we've done here is we've split off these two and then tried adding it to these two. So that doesn't work because, again, we know this 3 over 1 plus 2 again gives us 3 over 3, which gives us an answer of 1. But what they've split it to, so 3 over 1 would give us 3, and 3 over 2 would give us 1.5. So it'd be 3 plus 1.5. So we'd get 4.5. So as you can see, both of these two answers here, they are not the same. They are not the same. So bear that in mind. That's a skill that you can practice and test out. If you're ever trying to manipulate your fractions and you're not sure whether this rule will still be consistent with the answer, try and replace your variables with numbers like we did here. So try and replace your letters with numbers. Test it out. So let's have a look at doing a few examples together now. So first of all, we have to use multiplication to make the fractions have the same denominators. So then we add or subtract the numerators with like terms. So that's the important bit for us to start with. What are like terms? So we have our 2y and we have our plus 5y. So do we remember how we put squares and circles around like terms? So these terms are like because they have the same variable, the y, they have the same letter, and they are to the same power. So they're not y squared, they're not y cubed, they're not y to the power of 4, they're just y to the power of 1. Then we also have 3/5 x plus 1/5 x. So I'm going to deal with my y's first. I have 2 lots of y plus 5 lots of y, which is 7 lots of y. I then have 3 over 5 lots of x plus 1 over 5 lots of x. My denominators are the same, so I just add my numerators. So I get 4 over 5 lots of x. So there's my answer. Can you pause the video now and give yourselves 45 seconds working through the redo? Okay, so diving in, we have 2 lots of y and 15, positive 15 lots of y. So remember to keep the symbol before the term. It's very important. So I've paired off my terms now. So my x's are in the rectangles and my y's are in the circles, if you can call them that. So we have 2y plus 15y, which gives us 17 lots of y. And then we have, they're both positive terms, the fractions. So we have 3 over 7 lots of x and 1 over 7 lots of x. So I just need to add my numerators and I get 4 over 7 lots of x. Give yourselves the mark if you got that right. Great work. So next, again, I'm going to pair off my like terms. So I've got a 2y here, I've got a positive 5y here, then I've got positive 3 over 5x and negative 1 over 5 lots of x. So I'm going to deal with my y's first. 2y plus 5y gives me 7y. Then I've got positive 3 over 5x, subtract 1 over 5x. So my denominators are the same. They are like terms, so I just subtract my numerators. So I'm going to have 3 take away 1. So I'm going to get positive 2 over 5 lots of x. So pause the video and give yourselves 45 seconds again. Trying to solve through this second we do. So again, we've got 2 lots of y, 15 lots of y here. Then we've got 3 over 7 lots of x and minus 1 over 7 lots of x. So 2y plus 15y gives us 17 lots of y. Now we've dealt with our y's. We've got 3 over 7 lots of x, subtract 1 over 7 lot of x. So the denominators are the same, so 3 take away 1 gives me 2 over 7 lots of x. Give yourselves the mark if you got that right. Okay, so next, now we have some fractional coefficients, like we've got here, and they're negative, and then we have whole number coefficients. So the coefficient here will be number 1, because we have 1 lot of x. Then we have 5 lots of y, and negative 2 lots of y. So deal with the y's first. We have 5 lots of y, subtract 2 lots, so that's going to give us 3 lots of y. We then have this 1 lot of x, which we can say is 5 over 5 lots of x. And then we're subtracting 1/5 from that. So my denominators now are the same. So I'm going to do 5 take away 1, so I'm going to get 4 over 5 lots of x. So there's your answer. Can you now give yourselves 30 seconds now, so you can do a little bit quicker, working through this we do. So again, we got 15y, subtract 2y, which gives me 13y. I have 1 lot of positive x, subtract 1/7. So again, this here is going to end up with 7 over 7 lots of x. So subtract the numerators and we get 6 over 7 lots of x. Give yourselves the mark if you got that right. Okay, so now working through it, we've got a lot of fractions now. So we're going to say we've got 3 over 7 here, lots of x. We've got minus 1 over 5 lots of x. Negative 2y. And negative 5y. So because they've got whole number coefficients, I'm going to deal with the y's first. So negative 2y. And then we're subtracting 5. So on the number line, we're going to be going down. So it's going to be negative 7y. Now these two fractions, I'm going to want this one over 35. So I'm going to have to times the top and bottom by 5. I'm going to get 15 lots of x. This fraction here, I'm going to want 35 on the bottom again, just so that my denominators are the same. I'm going to have to times top and bottom by 7. That's going to be negative 7. So we've got 15 over 35x, subtract 7 over 35x, which is going to leave me with 8, which is going to leave me with positive 8 over 35 lots of x. So pause the video now and give yourselves 45 seconds again on this one. I don't want you to make any mistakes when you're changing your fractions to have the same denominator. So give yourselves 45 seconds working through this we do. Okay, so we've got 3 over 5 lots of x. We've got negative 2y. Negative 1 over 7x. Negative 15y. So I'm going to deal with the whole numbers first. We've got negative 2y. Subtract 15y. So we're moving further down our number line. We've then got 3/5 x, which I'm going to say I want 35 on the bottom again. So I've had to times top and bottom by 7. So I get 21 over 35 lots of x. And then this fraction here is negative. I want 35 on the bottom. So on the top and the bottom, I'm going to want to times both by 5. So now it's a lot easier. Denominators are the same. Just apply the operation to the numerators. So 21 take away 5 gives us 16. So we've got 16 over 35 lots of x. And that's positive. So give yourselves a mark if you got that right. Great work, guys. We've only got one more to do now, and then we can move on to some practice examples. Okay, so here we go. So we've got 3 over 7 lots of x, negative 6 over 14 lots of x, negative 2y, and negative 5y. So I'm going to deal with the whole numbers first. So negative 2y, subtract 5y, we're going to go further down the number line, so it's going to be negative 7y. We've then got two fractions, and I can notice quickly that this fraction here, if I times it top and bottom by 2, I'm going to get 6 over 14 lots of x, and there's my equivalent fraction, and now I have the same denominator. This here can stay as it is, as negative 6 over 14 lots of x. And as you can see, I've got 6 over 14 lots of x, and then I'm subtracting 6 over 14 lots of x. Let me put that here so it looks like it's not in the denominator. So they're going to cancel each other out, aren't they? So I've got negative 7y plus 0 lots of x, and that doesn't need to be written. So I'm just showing you that it's cancelled out there. So now on example 5, give yourselves 45 seconds to work through this final example before you move on to the practice exercises. Okay, so again, circle what's like, rectangle the other terms that are like. So I'm going to deal with the rectangles first because they're whole numbers. So we're at negative 2y and we're subtracting another 15. So it's going to get even lower down the number line. It's going to become even more negative. So then we have to look at these two fractions. So I can see here that I want my denominator. I have denominators of 5 and 10 at the minute. So if I times my 3 over 5 by 2, top and bottom, then I'll have both of my denominators the same. So I've got 6 over 10 lots of x, subtract 6 over 10 lots of x. So again, they cancel each other out. So I just end up with added 0 lots of x. And again, 0 times x just gives us 0. So you don't need to write that. Our answer is just minus 17 or minus 17 lots of y. Okay, so great work through this, guys. Now can you give yourselves, let's say, 7 minutes working through these, and then we'll have a look at showing the answers. Remember to use the success criteria and the examples and the 6 or so examples that we just completed. Okay, and here are the answers. Make a note of how many you got correct out of 12. Oh, 10, sorry. Make sure you make a note of how many you got correct out of 10. Great work today, guys. So now remember to make sure you're going on checking if you've got any homeworks on Hegarty. Make sure you're going, sending your work to your teacher. If you're really proud of the work, make sure you keep it somewhere stored and safe, and make sure you send a picture through to your teacher. I'm sure they would love to see it. I know I would. And now's a good time to reflect. What did you struggle with? Was it remembering to get the same denominator? Was it maybe collecting like terms? Because these are the types of skills that you can practice on Hegarty. Or can you think of your own way as to how you can get better and improve at this? All right, have a great day, guys. I'll speak